Today we are going to study sampling and estimation. Okay, for sampling, if I'm talking about, so first of all, the concept of the sampling you should understand. And if you know anything about sampling, so just let me know. Do you know anything? No. Sampling is exactly the chunk from the total of the population. For example, let's suppose if you are going to test a perfumes on a container, na? So the container is exactly full of perfumes. Okay, and it is understood that it will be having almost 5,000 to 6,000 perfumes, but you are not going to test everyone exactly. Am I correct? Because you will separately pick out a chunk from any of the portion, and you will just test them, and you will come to know about the conclusion for the whole container. Is that clear? Is that clear, Maha? So for example, let's suppose if I'm talking about a container, there was a total population for that container was 5,000 perfumes. But the sample that you select in order to go for the quality assurance, you just only pick the 100. Okay, that is your exactly sample size. Sample is exactly the chunk of the population, the total population, and which on that sample you can just construct the conclusion related to every particular thing that whatever you are going to test. Is that clear? Okay. So for example, how many processes do we have for the sampling and how we go for the sampling, just for the knowledge that you know about this thing, because you have to write somewhere you have to write some points related to that thing. So first we can say, like, most of the samples are drawn by after doing the survey, and the survey can be done from the, you know about this word census? Don't you know anything about census? Who did the first census and why do we do the census? Actually, the census is exactly the thing. Let's suppose you are in Saudi Arabia. So if I'm talking about Saudi Arabia, so they must have the budget for just put the amount on sports, medical, like health, education, and these type of categories. So always every country will be having the budget for putting some amount on this kind of particular society works. Okay, which will grow up the society, like just like that. If it's first of all they will go for the survey. Okay, they will figure it out that in whole of the country, which age persons are most likely to be. For example, they have set the target like 15 to 30, and then 30 to 60. So 30 to 60, they found that 15 to 30 are more than less than 15 and more than 30. So most of the people are in between this 15 to 30 age. So it means at that time they must invest on sports activity, on education as well. That clear? Because as we are having the most of the persons who are in this between age, so they must be getting the education and they must be going for the sports or the health activities. Hmm? But if we are having more than 30, age of more than 30, so in that case I am going to invest most of the budget on the hospitality, isn't it? Like for health, because of I am having a lot of elder age persons, so I must accommodate them. Is that clear? That how we decide the budget after doing this thing. So when I'm just going to ask every person in the country about their age and something like that, so it will be done by the way which is known as census. It's known as census. And some of the times on the census we always figure out any of the sample size, because we cannot go for the whole population now. because survey can be done on multiple of things we can do for the survey, but the best thing is that go for the census. So in census, what we do, every member is asked about any particular thing, and sample is exactly survey which help to conclude the result of 100% the population. Is that clear? You have got to know about the difference between the census and the sample. Census is always done with the whole population, like every person will be asked about that, and sample is exactly the small chunk of that population. Okay, so what are the sampling methods do we prefer? The first one is, did you take stats in O levels? Yes. No, that was an optional. I was just asking, did you pick the optional one? Stats. Okay. The first thing is exactly we call it simple random sampling. Random, you know about that word of random. Must be you have heard that word in the probability. Random, randomly pick something or something like that. So the random is exactly like we have a bag in which we have a lot of balls and we can pick only red balls, or directly we can just close our eyes and pick out the ball. So it is known as a random sampling. And sample, it is I'm talking about a simple random sampling. So simple random sampling, there are some rules for the simple random sampling. What is the current situation right now? Nothing. Draw lots, like write all the name. Sorry, write all the names on the chat and put name in a box. I'm just giving you an example and pick out chat. Okay. So let's suppose just like a lots. Do you know about the lots? Like lottery. So it's just every number is in the box and we just shake that box and suddenly we pick any of the particular number. So it's not known as simple random sampling. And random number table, there is one more thing that we follow in the sampling method, which is exactly random number table. Assign random numbers to all numbers and then pick them one by one. Okay, so there will be a particular range we can follow. There will be a question. I'm just helping out about that thing. For example, I'm having some of the numbers 6, 2, 3, 8, 5, 2, 7, 3, 6, 2, 4, 8, 5, 7, 4, 3, 0, 8, 5, 4, 1, 4, 7, 5, 9, 3, 9, 5, 5. Okay, so they are asking us use this random number table to select the random number of 8 people from group of 100 people. So for example, if I'm just going to pick out the random numbers, so how can I allow a random numbers to the every particular sample or random number table? So these are the random number table which can be given in the questions as well. Okay, to draw samples like this. For example, if I'm having a random numbers, like the random number, first random number is starting from 0 1. Okay, and we are talking about 100 people exactly, so we are going to pick out the 100 random numbers. Okay, now see this. uh, 0 1, first random number is 0 1, then second one is 0 2, then we are having 0 3, and so on. The second last number is 99, and the last number will be what? No, it's 0 and 0, because we are moving with the two digit numbers. Okay, so these are the hundreds, 1 2 3, and this is the 99, and this is the 100th value. Okay, got it? And furthermore, we are going to draw the samples over here. The samples can be done by that way. Like the first number of the two digit number that I told you that we are talking about a two digit number. So this is going to be the 68. That is my first random number. Okay. And then what I'm going to have 72. Then furthermore 53. Then 81. And then 59. And I can keep on having that numbers. And at the last I can have any one of them like 05 or 70. If any of the number is remaining out, so we can put it out. Okay. Is that clear? Now these are the method for the random sampling now, and this method can be done by that way as well. Like for example, if they are telling you to pick out a random sample of 8 people from group of 60 people. And one more important thing that I want to mention it over here. When you are going to make the random sample of 8 people now, so it is going to be the 8 particular random values. Okay, so just like this, it's the first value that you are having, and like let's suppose it's a second value, third value, fourth value, fifth value, and then after that what you are going to have 59. After the 59 we are going to have 25, and that is 34. How many numbers do we have? 1 2 3 4 5 6 7, and one more, that is 70. These are the 8 numbers that we are going to pick randomly. Okay, and when they are talking about random sample of 8 people from a group of 60 people, so how can we proceed with this one? The first is going to be the same. For example, random number for the two digit is 01, 02, 03, and so on, and the last we would be having 60. Okay, because it's a two digit number. So now I can proceed with this one. I can pick out any of the two numbers set by this condition. But what we are going to do, I am just making some conditions for that thing. You know what is the conditions? I am just making conditions. For example, they were telling me like a group of 100 people. So it means less than 100. So we were just putting the numbers, 8 numbers I put. Now they are asking about a group of 60 people. So I am just going to pick only those numbers which are less than 60. Okay. So when I'm talking about 68, I cannot pick that number. Can I? And 72. No. 53. Can I pick that one? Less than, no? And 81 will not be picked, but 59 will be picked. So we have to go for only 8 numbers. So again, I'm going to have 53. I have just only picked 59, then 25, 25, then 34. Then we cannot pick out 70, so we will pick 54. Then we cannot pick 95. Then we will go for 32. Then we cannot pick 66. We can go for 44. 1, 2, 3, 4, 5, 6, 7. And then we will be having 47. Okay, these are the numbers. Are they 8 or not? 3, 6, 7, and 8. Yeah, they are 8. Is that clear? This is the criteria to pick out the numbers over here. Okay, now we will proceed with the statistics of the sampling. Just a second, one more thing I want to mention. Okay, what are the statistics of the sampling? What is exactly the statistics mean? Hmm? Numbers or a symbols means the calculations. What sort of calculations you can do? Sorry, beta. No idea. Great. Now see this. Let's suppose your x is exactly the population. And remember this thing, when the x is exactly the population mean I'm talking about. So at that time, x bar will be the sample mean. Do you have any idea about that thing? Sample mean. I'm telling you, like, let's suppose you are having a population of the 1,000 persons, and if you are just taking a mean, you are calling it x, capital X. But when you are calling it x bar, so it will be representing you sample mean. Like the 1,000 persons was a population, and there are 25 was the sample. So the sample mean is exactly x bar. Okay, and then we can also have that one, like when we are having x is the population, and we can also have that one expected x for the mean. You have also had it. Hmm? And the variance of x will be considered in this way. This is the variance. Do you remember? And when I'm talking about the mean for the sample distribution, for example, the mean of this sample mean, like the expected x bar, it will be mu exactly. Okay, and the variance of x bar will be sigma square over n. Okay, so the variance of the population will be divided by n. N is exactly the sample size. Yes, exactly. Yeah, but when the sample is distributed normally, it depends on the conditions. And these are the same things that are going to use in the hypothesis when n is greater than 30 or less than 30 or set a limit theorem. All of the things are belonging. So sigma square over n exactly the variance for the sample one, and n is exactly the size of sample. Are you writing? Note it down. So the case number one is exactly population of X is normal. So in that case, value of variance sigma square is known. Okay, remember one thing, like when the population of X is distributed, is normally distributed. Na? So in that case, you have to know that the variance will be known. Okay, this is the case component. And what we are going to show exactly, let's suppose X is following a normal distribution with a mean of 100 and 64 is the variance. In that case, I can say this 100 will be over here. Okay, because this is the mean exactly. And when I'm going to just increase the value, so you will come to know about that why we are dividing something like this. Like for example, if we are having a different sample sizes now, for example, what will happen when I'm just going to increase the sample size? Any idea with the curve? Huh? N is what the top one, 100. N can be anything, I do not know. But when I sorry, listen to here, this axis is the population. So population are providing you the values of mean and something like the variance. But when you are just going to pick the sample of two values from this population, so what will be happening with the curve at that time? That's what I'm asking. Divide something by 2, divide, I guess dividing the variance by this one now. Variance by 2. Yeah. So in that case, what is going to happen? Let me tell you. It's the same thing that will be happening for every particular value. For example, n is 2. So in that case, your data will be like this. Okay. And whenever you are just going to increase the sample size, okay, so the height of the curve will be increasing and the size of the curve will be stretching. Means stretching with a scale factor of 1 upon a. I guess you call it a squeeze. Yeah, stretching by parallel to the y-axis. Yes, stretching by parallel to the y-axis. So do you know what is this happening over here when I'm increasing the sample size? And the sample is small, so in that case, the variance of the data is exactly spreaded. And when I'm just increasing a sample size, so every particular increase, the spreaded data is going to be squeezed together to the mean value. Okay, and you can see the effect over here. Like for example, 64 divided by 2 under root 2, because it's a variance square upon n. No? Yeah, sorry. 64 divided by 2 and 64 divided by 5 and 64 divided by 30. So every time when I'm increasing the sample in the denominator, so the variance will be going lesser from the previous value. The variance is low, and that mean that the data is not totally spreaded. Okay, it is close to the mean. The thing which I just told you right now, no, that was a question in 2018. 1 mark, 1 or 2 mark. This is the basically the description of any of the calculations. Na? So at that time in the part A, they just give the sample of N10, and in part B, I guess they just give the sample of N35. And on the behalf of the calculation, they were asking about the conclusion of the last part. Okay. Now let's take a question related to that thing. Like X follows a normal distribution with the 25 is the mean and 340 is exactly the variance. Over here, they are telling me that mean of random sample of size n is drawn. Mean of random sample of size n is drawn from this distribution, but it did not tell me exactly the size of x bar. So what we are need to find value of n correct to two significant figures, given that probability of x bar is greater than 28 is approximately 0.005. Okay, so the probability for x bar is greater than 28. So it means they are exactly talking about a sample. So when I'm talking about a mean, the mean is going to be the same in that case, but the variance will be changed according to the calculation. So when I'm considering that thing, like according to the question, my x was normally distributed with 25 and 340. So in that case, when I'm talking about x bar, so x bar is normally distributed with mu and sigma square upon n. This is the variance for that case. Okay. So over here, my mu will be the x, expected x exactly. So I can say that my mu is exactly 25 and sigma square is exactly 340. But when I'm dealing with this sample, na, the sample variance means variance of x bar. It will be 340 by n. Is that clear? And your variance, oh sorry, your expected x bar will be the same, that is 25 over here. Okay, so this variance, if mean is greater than 28, yeah, mean is 25. They are talking about the sample over here. Na? That is a normal distribution. Means the total population. Total population mean is 25, but they are expecting that the sample mean should be greater than 28. Not necessary. We do not know that. We have to prove it or we have to calculate it. That's it. Population mean and sample mean can be replaced each other for the calculations, but they are not equal exactly. They can be changed because it depends upon the sample size that we are having. Okay, so now I am going to deal with this one. Probability of x bar is greater than 28, which is equal to 0.005. And one more thing, when I'm interested to know about the standard deviation for this SD of x bar, it will be considered as 340 by n. Is that clear, na? Okay. As we do the questions, simply we are going to solve that one this way, like x bar minus mu divided by sigma means standard deviation will be greater than 28 minus what, 25, and divided by the standard deviation, which is exactly 340 by n. Okay. You know that. And how can we proceed with this one? Like on the normal distribution table when I'm talking about. So it will be like this. At that time 0.05, it's a greater than value, huh? So this area must be 0.05, which cannot be seen on your normal table. Sorry. No, no, it's greater than, see here. It will be greater than by this value, and this area will be considered as 0.05. Okay. And this value we do not know, because in order to check this value we have to jump in the table probabilities, and for the table probability we do not have the probability of 0.05. And remember this thing, that a normal distribution table always gives you the probabilities for the left hand side, or the range left hand side always gives you. So you need to get, no, shaded part is the right hand side, but a normal distribution table gives the values on the left hand side. So we will do 1 minus 0.05. So sorry, 0.005. It will be, I guess, 0.995. Uh-huh. Is it 0.995? Yes. I have the normal table, right? This one, 5, 7, and 6. Oh, 2.576. So this value is exactly 2.576. So what I'm going to do, like z was greater than 28 minus 25 divided by under root of 340 over n, and that was 0.005. And on the other side I can say that z is greater than 2.576. It will be 0.005. So we can compare both of them. I need to connect it to the charger. It is irritating a lot. It's not charging in the morning. 50.7. So they were asking about the two significant figures, the sample size. So we can say that n will be 250 in that case. Okay. Okay, that was a case number one. Now what is the case number two? When x is not normally distributed. So at that time we use CLT, and CLT is what? Cen- Central limit theorem. Central limit theorem. And for applying the central limit theorem, n should be, means the sample size of n should be greater than equal to 30, and we will consider that it's a large n. Okay. And when we are dealing with this, where the n is large, what comes in your mind when the n is large? Normal distribution. Very good. So it means when the n is large, so we can conclude that x bar is normally distributed. Okay, means the sample is normally distributed. And at that time, the sample will be normally distributed. It means the sample will be treated as a normally distribution. Okay, but at that time, what will be happening with the population one? Okay, that is an important thing. Like we have to know each and everything about that. Like for example, if I'm talking about x is a sample, oh sorry, population. The population can be in two different modes. Like it's a normally not normally distributed, so there are two distribution that we have: the Poisson distribution and the binomial distribution. Hmm? According to our syllabus. So if the x is on Poisson distribution, or your x is on normal distribution. Oh, sorry, binomial distribution. So we can say that x follows a Poisson distribution with lambda is exactly the point, exactly what we have. So the mean, which is exactly expected x, or we call it x bar, it will be for the sample, it will be lambda, and the variance for the sample will be lambda over n. Is that clear? So it means your x will be following the normal distribution by mean is lambda and the variance is lambda over n. And when the distribution is exactly binomial distribution, so what we do, like x follows a binomial distribution with n and p. So at that, yeah, so the mean is exactly mean of sample is going to be np, and the variance of sample will be npq. Okay, so here x bar follows a normal distribution with the mean of np, and the variance is npq. Npq over n. Sorry, are you writing it? Sorry, beta. You have noted down? P is always given in the binomial probability of success. Yeah, it always be given. Okay. There is one more distribution, which is known as distribution of sample proportion. I guess you have seen in your calculations. I mean that when your teacher was explaining at that this is stuff, na, in the class, you have some sort of visual memory of this sample proportion. Sample proportion probability is exactly proportion, which is p cap, and sample size for that one is exactly n, and probability of success is exactly p s, and probability of failure is exactly q s. Okay, and over here proportion means that they are exactly talking about the probabilities. Okay, so don't get confused in that one. You know the formula for this? That is for the confidence interval. Yeah, it is a confidence interval that is an estimation, but we are doing right now the sample. Very good. You tried by yourself. Without knowing anything. X will follow the binomial distribution with NP. So the expected X for this one will be NP, and the variance of X will be NP. Okay, now I'm going to tell you anything. So, for example, this is your exactly the sample now. Okay, the whole sample in which you are just dealing with the small chunk. It's chunk in the sample that will be considered as X. For this one, what should I say? Proportions. Proportion sample can be figured out by this X over sample size. Okay, so exactly this is the definition for the proportion. Proportion means that now you are having any of the particular sample, or in that sample you are just going to figuring out any of the particular chunk. Okay, Just like that, if you are interested to know about the probability for this x now, what you will do? This area divided by total area. Hmm? So it's exactly the proportion of the sample. Like now you are calculating the proportion for the sample values. Let's suppose that was a total population and that was a sample in this portion. So at that time you are getting the proportion for the whole population. Okay. And for this condition, when we are going for the proportions, so we must know that proportion sample will be proportion and the variance of proportion will be equal to PS, QS and NS. PS is exactly the success of the proportion. Oh, proportion success, and QS is exactly the proportion failure, which I have mentioned at top. And N is exactly the sample size. This is the new formula that you are going to learn because you haven't seen this formula before. Variance. What do you mean by distribution formula? Distribution is this one. This is the total population, and that was a binomial distribution. And the variance for that one was NPQ. But when we are dealing with the proportion, distribution for the proportion, so at that time, the variance will be PQ over N. Yes, yes, exactly. Fraction of that sum. Yeah, it follows the binomial, but I do not use the binomial distribution formula. Mean will be exactly the proportion what we are having. For example, I'm telling you. For example, let's suppose the proportion was 0.5. Okay, so the mean will be 0.5 exactly. Mean will be same. The proportion will be only consider the proportion. And let's suppose if you are having, for example, you are having a proportion 0.3, so that will be the mean exactly, and the proportion 0.3 into 0.7 divided by the sample size. Yes. Either they give you exactly the proportion, or sometimes they will provide you the values to figure out the proportion. Okay. And what about this one? When your n is large. When your n is large, so in that case, the binomial follows normal distribution. Okay. So, for example, that will your proportion. Gonna be proportion sample follow the normal distribution with the mean of PS and the variance of PS QS over NS. It's going to be the same. Okay. But over here, when we are converting the binomial to the normal, so you must know that you have to adjust the continuity correction. You know about that thing? Yeah. Mm. Continuity correction is always be plus minus 1 upon 2, which is exactly plus minus 0.5. Ma, can we keep till here? Then we can proceed with this lecture into the next class. I will to start with the continuity correction and then explain you this one. Then we will go for the questions because the one of the question which is related to directly this one. Fine. You will be having a class on tomorrow at 11. My 11. Your 9. Okay. Thank you, beta. Take care.